Good morning.
Good morning.
All right, so what's going on today? Let's see, anybody absent in Holbrook? Looks like everybody's there.
Everyone's here.
Awesome. And let's see, there's Jill. Okay, so I guess we're good. And Joseph City as well, so awesome. All right, and let's see, who was it that said they had to leave early today?
Oh, that was me, but it's okay. I'm in the same class.
Okay, all right, good deal. All right, well, so tomorrow we are going to do quizzes 7-1 and 7-2 during class time tomorrow. And I would just say a word of caution is that in compared to some other quizzes, I think a lot of these questions are easy as far as, working with the identities, but the word of caution is be careful. Be careful. Watch the signs carefully, that kind of stuff. So just kind of a word of advice there. All right. So any questions, comments, concerns before we get started today on 7-3? All right. Well, let's go ahead and get started. Okay, so 7-3 is on what's called product sum identities. And so they're actually kind of broken down into 4 different categories. So double angle identities, power reducing identities, half angle identities, product to sum, and sum to product identities. So the idea is to not have you memorize all these formulas and identities, but to feel comfortable in using them and applying them to different situations. Okay? So let's start with let me just say what they look like. So when we talk about the double angle or multiple angle identities, we're going to have like the sine of 2x or the cosine of 3 theta. The second category is where we have the power reducing formulas. That's when we have like the squares. So like sine squared x or whatever. And then the third category we'll have half angles, and they look like this, where we have like the sine of u divided by 2. And then the fourth one is when we have products. So like sine u, cosine u, like that. Okay? So the first group are the double angle formulas. And so these are the most commonly used of all the multiple angle formulas. Let's see. So the most commonly used are the double angle formulas. So and so there, I asked you to go ahead and list those. Now the thing that's interesting about this is probably the sine of 2u is used absolutely the most. Cosine 2u actually has 3 different versions of the identities. And so you actually use whichever one you want or whichever one is most appropriate in the problem. Okay? The tangent 2u, this is the formula that's in the book. So right now I would like you to add that also to the tangent 2u. This is a formula that's not in your book, but if you already know the sine of 2u and the cosine of 2u, then you can just divide those and get the tangent of 2u. All right, so let's give you an idea of how we're going to use these. Well, actually, let's go back and show you. Let me derive one of those. You don't have to write this down if you don't want to. I'm not going to ask you to derive any of these formulas, but I'm going to just give you an idea of kind of where they come from. All right, so you remember yesterday we had this formula, the sine of u plus v, and we used this formula, okay? Now, suppose that we had the sine of 2u. Well, that's the same as the sine of u plus u. And so we go back and use the formula from yesterday, and we plug in u for v as well. And so we get sine of u cosine u plus cosine u sine u. Well, the order that we write it, a product doesn't matter. So this is the same as sine u cosine u. So we end up with 2 sine u cosine u. And so that's where that formula comes from. So the sine of 2u is 2 sine u cosine u. Okay? All right. So, now one thing that's going to help us, there's a couple of little tricks here. One of them is if you know the sine or the cosine, to find the other, you can either use a triangle or you can use the Pythagorean identity. See, we've always used triangles up to this point to find the other trig functions. But you can also use the fact that sine squared plus cosine squared equals 1. So, for example, if I know the sine is, or if I know the cosine is -2 over radical 5 squared, then I could plug that in to this equation and solve it for the sine. Okay? So there I would square it out, subtract from 1, and then take the square root. Now, if we don't know, okay, so it's plus or minus when you take the square root. So hopefully if it matters, we'll know what quadrant we're in. So if we know what quadrant we're in, then we can know if the sign is positive or negative. Okay? So we'll kind of focus on that a little bit more, but I just want to tell you about this algebra trick that we're going to be using in this section. Is using the trig identity there. Okay. So the other thing that will help us is we're trying to find other sides is if you remember some of the Pythagorean triples. So like a 3, 4, 5 triangle is the most common, or any multiple of that, like 30, 40, 50. So if you know that, you don't even have to use the Pythagorean theorem if you can remember that relationship, because 3 squared plus 4 squared is 5 squared. The other common Pythagorean triangle is the 5, 12, 13. And so 5 squared plus 12 squared is 13 squared. And so those are common ones those can save you time if you remember those. All right. Okay, so let's say that I'm told that the cosine of theta is 5/13, and I'm in quadrant 4, and I want to find the sine of 2 theta. Okay. All right, well, so there, what I do is I say, okay, to find the sine of 2 theta, I'm going to use this formula. So 2, and see, I know cosine theta, I can plug that in, but I don't know sine theta. Okay? So where is that going to come from? Well, I'm going to draw a triangle here in quadrant 4. And so if I know the cosine is 5/13, so here's my theta. So that's adjacent over hypotenuse is 5/13. And I know my Pythagorean triple is 5, 12, 13. So I know this is 12, but since it's going down into quadrant 4, I'm going to label it as negative 12. So then the sine of theta is negative 12/13. Okay? Did I do that too fast? Anyone have a question on that? On how I got the sine of theta?
Yes.
Okay, so let me go through that again. So if I know the cosine is 5/13, and well, I know I'm in quadrant 4, so that's why I drew my triangle this way. It's because I'm in quadrant 4. So that I'm going to have the angle go down into quadrant 4. So then the cosine is adjacent over hypotenuse. So I drew the adjacent as 5, the hypotenuse is 13. And so then the length of this other side is 12. But since it's going down, I labeled it negative 12 because cosine is going to be negative. I could just label it 12, but then put the negative here when I'm writing the sine because the sine is negative in quadrant 4. Okay? So now I plug in, I've got 2, I've got the sine of theta is negative 12/13. I've got the cosine of theta is 5/13. And so now I simplify that and I get negative 120 over 169. Okay, so let's just stop there. So what I want you to do is on practice 1A, just find the sine of 2x. So I've given you the cosine, so you find the sine of 2x. All right, so Anna, when you've got just the cosine of 2x, or excuse me, the sine of 2x. Actually, just tell me what the sine of x is. So if the cosine is negative 2 over radical 5, if that's the cosine, then tell me what the sine is. So you can either use a triangle or the Pythagorean identity. Say again, please.
Square root 1 over 5.
Okay, so how about 1 over square root of 5? Let's see, do I have that over here? Okay. So it would just be 1 over the square root of 5. Well, oh, you said the square root of 1. Oh. Yeah, it's just, so the square root of 1 is 1, but you still have the square root over the 5. Okay? So everybody okay with that? So the sine of x is 1 over radical 5. Okay? All right, so Andres, what is the sine of 2x then? So Andres, you just plug into this formula here. So the sine of 2x, what is that?
It's on.
Yeah, I need help.
Okay, so what's the sine of x?
1 over radical 5.
And what's the cosine of x?
Negative 2 over radical 5.
Right? So if you just plug those in and then multiply out, 2 times 1 times negative 2 is negative 4. And then radical 5 times radical 5 is just 5. So the answer I was looking for is negative 4/5. That's the sine of 2x. Okay? So the next thing we're going to do, okay, so I'm going back to the example. Okay, so this is not your sheet, so just watch this. Okay, so now I'm going to find the cosine of 2x or 2 theta. Okay, so I can pick any one of the formulas that I know. Since I know the cosine was 5/13 in my problem, I'm going to plug in here. So it's 2 times cosine squared minus 1. So if I square out the cosine, multiply by 2, and then I got a common denominator here. So I got negative 119 over 169. Okay? So that's for my problem. Now, it doesn't say it on the practice problem here, but I want you to figure out the cosine of 2x for the practice problem. Okay? All right, so Lauren, when you've got it.
I got 3/5.
3/5. All right, let's see. 3/5 is correct. Now, did you use this formula or a different formula? The 2 cosine squared u minus 1.
Yeah, I used that one.
Okay, so you don't have to use that formula. You can use any one you want. You should get the same answer. Okay? All right, so any questions on the cosine of 2u here? Okay.
Yes, I
Yes,
do
go
have
ahead.
one.
What?
So, how did you stick the numbers from practice 1A into that formula again?
Okay, so we were told what the cosine of u was. Right? So it's 2 times the cosine of u squared. So you square this, multiply by 2, and then subtract 1.
Oh, okay, got it, thanks.
Okay? All right, now let's go back to my example. Okay, so to find the tangent of 2u or 2 theta or whatever, we can use this formula, okay? But I think it's easier if you already know, see the sine. Well, let's see. Wait. Okay, let me go back up. See, this is a lot of work. Okay, using this formula in red, it's okay. I mean, but it's a lot of work. What's easier is if you use the formula that I gave you that was highlighted. See, if you've already know the sine of 2u, divide that by the cosine of 2u. See, in this case, the denominators cancel, the negatives cancel, and so it's a much easier calculation. Okay? So when you can do that, that's what I want you to do, because it's much easier. Okay? So now, going back to your practice problem, you've already found the sine of 2x. You've already found the cosine of 2x. So now I want you to find the tangent of 2x for practice 1a. All right, so Jay, whenever you've got it.
I got -4/3.
Okay. So -4/3. So if we do it by the sine over the cosine, so for the sine of 2u, we got -4/5. For the cosine of 2u, we got 3/5. So the 5s are going to cancel, so -4/3 is correct. Okay, great job. Any questions on that? All right. Okay, so we can also use double angle formulas to verify other trig identities. All right, so let me give you an example. Let's say I want to show that sine 3x is equal to 3 sine x minus 4 sine cubed x. Okay, now that's a little bit tricky there, but when you see sine 3x, then think of it as sine 2x plus x. And so now that you're going to use the u plus v formula and say that's the sine of u plus v, sine of u cosine v plus cosine u sine v, okay, from yesterday. So now everywhere there's a u, I'm going to plug in 2x. Everywhere there's a v, I'm going to plug in x. And so that's going to give me sine 2x cosine 2x plus cosine 2x times sine x. All right, well now where I have these double angles, now I use the double angle identities on those to simplify. So sine 2x becomes 2 sine x cosine x times cosine x. All right, and then now remember there's 3 different formulas for cosine 2x. Why did I pick this one? Well, because I knew I had to get a sine cubed up here. So I picked the one that had an exponent for sine. Okay? So then times sine x. All right, so now let's go ahead and multiply this out. So that would be 2 sine, and then cosine times cosine is cosine squared. Sine times 1 is sine x minus 2 sine cubed x. All right, so we've got a sine cubed x, but we don't have minus 4 sine cubed x. We have minus 2 sine cubed x. All right, so what we're going to do to get more powers of the sine, I'm going to rewrite cosine squared as 1 minus sine squared. And then when I multiply it by 2 sine x, then let's see if I get more powers here. So 2 sine x times 1 minus sine squared x. So 2 sine x times 1 is 2 sine x. And then 2 sine x times negative sine squared x, negative 2 sine cubed x. All right, so now if I combine like terms, I have 2 sine x plus 1 sine x is 3 sine x, and then minus 4 sine cubed x. And that's what I wanted. Okay? Now, I'm going to warn you that sometimes it's hard to figure out which formula to use, or where you're headed. But looking at, so here this kind of lets me know, oh, I need that sine cubed. And so that kind of let me know which formula to use. Okay? But that's just going to take some practice. All right, so see if you can do practice 1B. But it's going to start off the same here. Your first few steps are going to be the same, at least until this point. All right. Okay, so Andres, where do I even start on this?
It was just the same as the other one, right? So it's like equals sine parentheses 2x plus x.
Good. Okay. All right, now, so then I break down sine 2x as what? What does sine 2x equal to? What's the formula for that?
Two sine cosine.
So 2 sine x, cosine x.
Yeah.
Okay, now, so the cosine 2x, there's 3 different ways I could break that down because there's 3 different formulas for cosine 2x. Okay? Now look at what the answer's supposed to be here. So which one should I pick for cosine 2x?
I would say the last one just because it has just sine in it, and you're probably gonna want to end up with all sines.
Well, except
Oh,
I want
fine.
I want cosine squared too.
Yeah, that's true. Okay.
So I'm going to use that one because it has a cosine squared and a sine squared in it. Okay? So in black, these are the 2 formulas that I'm going to use to substitute in for the underlying parts. Okay? All right, so then when I simplify, so I have 2 sine times cosine, so that's 2 sine x cosine squared x. And then when I distribute the sine through, I get sine x cosine squared x minus sine cubed x. All right, now what? Anybody? Can anybody tell me what to do next?
Couldn't you combine like the 2 sine x cosine squared x plus sine x cosine squared x?
That's right. So then what would I end up with?
3 sine x cosine squared x.
And that's the answer. Okay, good job. So it's just combining the like terms, and sometimes it helps to look back at what I want for my answer, and I'm like, oh man, I'm close. All I have to do is combine those like terms, and boom, I'm done. Okay?
But how does that prove it?
Well, because we started off with just sine 3x, and then we broke it down and simplified till we got what was on the right. So that's how it proves it. Okay. All right. So, all right, let's go on to the next set of formulas here. All right. So next, with the double angle formulas can be used to obtain the power reducing formulas. Okay. Now, the power reducing formulas are how to get like sine squared. I mean, this looks more complicated, but it doesn't have a power. And same thing here. None of these have powers on them. Okay? And so that makes it very useful. So like in calculus, for example, it's way more difficult to do calculus on sine squared than on this. Okay? Even though it looks more complicated, it's much, much easier. Okay? So just to kind of show you, for example, where one comes from. Remember, this is one of our cosine 2u formulas. And so then if I subtract the 1 or add 1 and then divide by 2, then I get the power reducing formula. So it's a way to take to the second power down to the first power. Now, I do want you to notice, though, that the angle is doubled. The angle is doubled. All right. So this is express sine to the 5th x in terms of only the first powers of sine and cosine. Okay? Well, if I write sine to the 5th as sine squared times sine times sine, then what I'm going to do is use that power reducing formula twice. And so I'm going to have 1 minus cosine 2x times 1 minus cosine 2x times sine x. Okay? And that's all we're going to do on that. Okay? So it's just applying the proper formula. Okay? So go ahead and try practice 2. All right, so Madison. All right, Madison, you need some help?
Oh, yes, I took it.
Would it be the 1 plus cosine 2u over 2 twice?
Okay. So, yeah, so you're going to have that twice. So 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2. Because you break it down to the fourth is cosine squared times cosine squared. Okay? And that's all I wanted on that one. All right, any questions? All right, good. Okay, next, the half angle identities. Okay, so this is the sine of x divided by 2, or u divided by 2 is how they have in the books. Now, a couple of things about this is that where it's plus or minus, this is not the plus or minus like we have when we're doing the quadratic formula and you have two answers. This is literally plus or minus, but not both. So you don't have two answers. The plus or minus is determined by the quadrant you're in. Okay? So please make a note of that it's not two answers. So if you put like plus or minus on one step, you got to make sure you figure out which it is. Okay? You can't have that in your final answer. The second thing is that I've also added this formula that's not in the book. So the tangent of x over 2, that there's two formulas for that. Or if you've already calculated the sine of x over 2 and the cosine of x over 2, you can just divide those, and that will give you the tangent of x over 2. And usually that's the easiest way to do it, if you've already got it. All right? Any questions? All right. So let's say I wanted the exact value for the sine of pi eighths. All right. Now, first of all, that's not on the unit circle. But when you see the word exact in there, that means you're not using your calculator here, unless you want to use it to check. But it's not going to give you the exact value. Now, if you want, you can, now, and this is the formula I'm going to use, the sine of x over 2. Okay. Now, if you want, you can actually convert this to degrees if you want. But I'm going to just do it in terms of radians, and then you tell me if it would be easier for you in degrees. So the idea is that you figure out, okay, x over 8 is half of what? I mean, pi 8 is the same as half of pi fourths. So if you think of your x as being pi fourths, then pi fourths divided by 2 is going to be pi eighths. So then it's going to be plus or minus radical 1 minus the cosine of pi fourths over 2. All right? Now, the cosine of pi fourths is radical 2 over 2. All right, now, here's the thing, though, is that we don't really like this complex fraction here. So how can I get rid of this little 2 here that's bothering me? Because a fraction inside a fraction, that's no good. So how do I get rid of a complex fraction? What's the algebra trick?
That is technically rational.
Say it again. I didn't quite hear that.
Okay, I have an idea.
All
Can't
right.
you cancel out those 2's and have it be 1/2 minus radical 2?
So cancel out these 2's.
Yeah.
Okay. So you're saying if I had like 1 plus 2 over 2, I could cancel the 2's?
No.
Yeah, you can't do that. You can only cancel factors. Okay. But that's a good idea, a good thought. But no, that's illegal. I want a legal thought. How do I get rid of complex fractions? If I had x over 2 divided by 3 over 5.
Multiply it by the denominator.
Yes. So the only little denominator I have is a 2. So if I multiply both numerator and denominator by 2, I'll get rid of that 2 right there. Okay? So when I multiply by 2, then I'll get 2 minus just radical 2 over 2 times 2 is 4. Well, so now this radical 4 will actually come out to just be 2. And so I can either leave it like that, or if I want to pull the 1/2 in front. So it's 1/2 square root of 2 minus the square root of 2, or you could put it as that over 2. So I know this looks weird, but this is how the answers are going to look for most of these. Okay? So that's the exact value of the sine of pi 8, or 22.5 degrees. Okay? All right. So let's see if you can do the cosine of pi 8. Wait. I forgot. How do I know, as far as figuring the plus or minus, how do I know that it's plus and not minus?
This is a good time to just delete.
This is a good time to what? How do I know that the sine of pi 8 is positive and not negative?
Determined by the quadrant.
By the quadrant. Pi 8 is in quadrant 1. The sine is positive in quadrant 1. Okay? All right, good. Okay, so now go ahead and try practice 3A. See if you can find the exact value of the cosine of pi 8. All right, so Jay, when you've got it.
I'm gonna need some help with that one.
Okay, so pi 8 is half of what? What angle?
Pi 4.
Pi fourths. Okay, so we're going to plug in pi fourths over here. So what's the cosine of pi fourths?
Radical 2/2.
Good. So, okay. All right. And how do I get rid of the 2's? The 2 down here?
Multiply by 2.
Multiply everything by 2, top and bottom. And now the 4 is going to come out because the square root of 4 is just going to be 2. And now, is the final answer going to be positive or negative?
Positive.
Positive. Because the cosine, because pi 8 is in quadrant 1, cosine is positive there. So my final answer is, you could write it either of these ways here. All right, so let's do one in degrees, and then you can kind of decide.
I have a question on that last one.
Yeah, go ahead.
How did you take the 4 out as a 1/2?
Because the square root of 4 is 2, and so you could either leave it like here. See, notice the radical, the 2 isn't underneath the radical anymore. So the square root of 4 is 2, so you could either leave it down there, or it's 1/2 out front. Okay, but it's the same thing. All right, so when we do this last one here in degrees, you can determine if you want to just convert from radians to degrees and do them in degrees. But the sines of the sine of u over 2 and cosine of u over 2 depend on the quadrant of u over 2. So it's the quadrant of the original angle. Okay? So sometimes it's safer to actually figure that out before you even do the problem. Okay? So let's just jump to the practice here. So we want the exact value of the sine of 105. So just think about what quadrant is that in? Two. And is the sign positive or negative in quadrant 2? It's positive. So it might be good to just figure that out ahead of time. Okay? I guarantee one of the wrong answers is going to be if you get this wrong sign there. Okay? All right. So see if you can do that problem really quick. But you know the answer is positive. All right, so Cyrus, when you've got it, or if you get stuck, let me know. All right, well, we're running out of time, and I don't see you writing. So let's just go ahead and work it. So 105 is half of what angle?
$210.
210. And see, 210 is on the unit circle. Okay? So you can look the exact value up for that. So we know the answer is positive. So we didn't put the plus or minus here. So it's going to be 1 minus the cosine of 210 over 2. So what's the cosine of 210 from your unit circle?
Seven pi sixths.
That's the angle. I want the cosine. So the x value there.
Negative radical 3 over 2.
So negative radical 3 over 2. So it's 1 minus a negative radical 3 over 2. So that becomes plus. So 1 plus radical 3 over 2. Then you do the same little trick where you multiply everything by 2. And then you're going to get